So for our next talk, we're going to have the co-founder and CTO of Astria, Jordan Oroshiba. He's going to give us a talk on what if we innovated faster.
Thanks for bearing with us and rolling straight through here. So I'm going to talk about what if we innovated faster. And because I'm an engineer and we've all done it at some point, we go and we fix a bug and we ship it to prod. I want to know what if we innovated faster and we did it in prod. So to take a step back real quick, just as we get in, there will be a number of points in this. You're like, wow, he's a tech boomer. That's going to happen. That's just who I am. And we'll have to roll with it. So to start with, I want to kind of go back and talk about like what is the core of crypto, and like crypto is what. And when I got started working in crypto, what I was told is that crypto is financial rails, and I think this is true in certain ways that we use crypto. It's financial rails. The way that I have described using crypto a number of times is that I say that crypto is just a database technology. And these will come back through sort of over the course of the talk here. I stand by this, but I think it's a little bit simplistic. It's a way to make everything we do sound much more basic and less cool than it is. Crypto is also just like a research field. I think the reality is that outside of a lot of work doing, front-running shitcoiners, we sometimes struggle for like product market fit. And so crypto is research. We're continuing to look and explore and find ways that we can use this. And that's at the core, crypto is actually about innovation. We're trying to find new ways to do things. Some of us are looking for ways to change the world. Some of us are saying, what if we could just do things a little bit better? But at the core, we're trying to change the way that technology we use every day works. And so to skip forward here, I'm going to say that smart contracts are a platform for innovation. And this kind of ties back into what I said about crypto fundamentally being a database technology, which is that when you are building normal software, you go and you say, I'm going to do an upgrade, I'm going to change things, and you just go and you like migrate your whole database. Crypto being a database technology, it's really hard to do that. Once you ship your state, you're kind of stuck with it forever. Smart contracts make this a lot easier. Instead of having your state transition function ingrained into everything you're doing, you can write a smart contract. You can upgrade it. You can make changes. We have languages like Solidity, the JavaScript of crypto, which not like JavaScript at all. If you write it wrong, everyone loses their money. Really bad. That doesn't happen when you write the front end wrong. It just, the button doesn't work. So smart contracts are a platform for innovation, but they have limitations. Like I said, it's not actually the JavaScript of crypto. It's maybe inspired by JavaScript. It is more accessible than actually building a protocol, or you can build a protocol using a smart contract, but it's more approachable than building a whole blockchain protocol from the ground up. But they have limitations. We have had some really cool innovations come out, like Uniswap. And there's a whole bunch of other things that have come out that look kind of like Uniswap, but are a little bit different. And they all, like any field, there's some things different about each one of these. They innovate each other, new versions come out. It's great. But we kind of see this innovation come out, and then we see a lot of duplicates. And we see this even, we launched shitcoins, right? Like someone was like, ooh, that's fun. And then we launched thousands of them, and then we, debate which one's gonna go up each week, and based off of how Twitter goes, it goes up or down. And so I think in order to solve some of these problems, we have this idea. There's also fundamental things with using the L1. We had this idea that I've been guilty of pushing, that we want to make it as easy as possible to deploy a rollup as it is to deploy a smart contract. Why is that? It's like, well, with a rollup, you can actually innovate fast, right? The idea is like, oh, I now own my state transition function. You own this with the Cosmos SDK as well. But when you run a rollup, you don't have to go recruit hundreds of validators. You get to rely on, the baseline L1 for your validator set, and you can innovate. But I like this. It's a nice idea. Lots of people had said it, including us. There's a problem is that we said we're trying to innovate here, and what are all these rollups? Well, I've seen a lot of OP stack rollups, maybe some pre-compiles added in. We also have some, we have Nitro and Arbitrum. It's all the same state machine. We haven't actually innovated that much. We've just added pre-compiles, and then we have this issue of how do we integrate? And there's a variety of reasons that we do this. It's a lot easier to integrate with something that's already done. You can reuse your MetaMask tooling. You can reuse your Foundry tooling. You can not build a whole new rollup from the ground up. Once again, we are guilty here. We launched this back in December to It was free to create your own rollup. I'm sure many in this room did it. Everyone created two. Lots of compute resources were used. Nothing was actually created that was particularly innovative. We instead just launched a whole bunch of Geth rollups. And this comes down to building blockchains is hard. And why is building blockchains hard? So like, there's a lot of stuff that goes in. There's a lot of stuff that goes into a blockchain. There's a lot of math. There's actual like cryptography, stuff that I am not an expert in, but is important to have right. And we have all of these components, and there's individuals in this room potentially who are experts in any single one of them. But if you are a new company coming in and you say, I want to launch an innovative new protocol, are you going to have an expert on a new way to do consensus, a new way to do P2P, a new state transition function, a new storage, God willing, a new way to do web servers, because I'm really tired of JSON RPCs. But usually you don't have someone who's doing all of this. It's like, okay, what is the layer that we actually want to innovate at? Well, I think the answer is kind of all of these. We have people doing cool new consensus things. Espresso has their innovative way to do consensus with a hot stuff. I always forget which one. We have P2P. The CometBFT group continues to try to improve theirs. We have libp2p. State transition functions, we have a lot of innovation here. This is where I think most of the innovation is really happening because we want to have different state. We have blockchains. We want different state on them. We want to try different ways to do it, whether that's prediction markets or it's DeFi apps or it's games or whatever it is. You have different state that you want to store in a blockchain. And again, I'm going to be boring. I'm going to say blockchains are databases. You have different state you want to store in it. But it's difficult. If you want to you can use Cosmos. You can build your own state transition function in Cosmos, but then you have to maintain a Cosmos app. You have to stay up to date on the updates. You have to recruit your validators. You have to ship all of that. So all of this stuff, and I actually purposefully didn't put DA or sequencing on here because that felt a little bit shilly. But like those are also components. And one of the difficult things is these are all intertied. When you have DA, that's consensus, but with P2P and pushing it all over those layers. When you have a sequence of things that inherently, a lot of things end up tying into consensus when we do this. Anyways, we want to innovate all over here. I think this is part of why, as Josh has said, we are all building the same thing, because at the end of the day, it is difficult. And there's some established patterns that we can do to create this. This is why we are all talking about modularity. Even the Solana folks are talking about modularity these days. Why? Is because we want to isolate all of these things so that we can innovate and move forward. And modularity, and kind of the way that I really view it and the dream of it, is that when we have true modularity, we can have different teams focusing on different items. It's not, I'm going to go raise some VC capital so that I can build from the ground up and have something wholly new. It's like, no, I want someone who is just a consensus layer expert to go and work on that. That's what you do when you work on the L1. You want to go and you want to work on your state transition function, new application ideas. We really want to make it easy for people to ship, iterate, test, and this is an earlier version of this talk was called research and prod. I want people to be able to do their research projects, test how it works on production data, launch with production data, and then iterate. So how do we unlock this? This is kind of, the core. I think it'll be a little bit shilly here, but the core of what we're trying to do at Astria, that I pulled these tweets in a different talk that I did. Dan Robinson and Uma kind of saying like, wow, it would be a lot easier to build rollups if you had 2-second block times and single slot finality. It just so happens that that's what we're doing. So it works out nicely that these other smart people seem to think that this makes things a little bit easier. And so you have that single slot finality, that 2-second block time. I think the other thing that we end up really tied on, and this is a little bit in the weeds here, but we developed this idea of an execution API. I'll talk about what our solution is, but in general, most blockchains end up having this. You have something like a beacon chain, you have a consensus client, you have CometBFT, and you need a way to drive the execution of that data. Whether it's CometBFT is less opinionated, but has a lot of steps involved with an ABCI. If you're using Ethereum and using the engine API, it's highly opinionated. You have to pre-execute before you can even send the block. Is a little bit confusing. So we developed something that's just a little bit simpler. We said, what are the basics of this? And I know I'm like showing code in a keynote, kind of weird. I'm an engineer. But the basic idea here is that you have the absolute basics of what you can have in a block. What does a block have? It has some sets of bytes and transactions, has a timestamp, and you know what it's on top of. Otherwise, you don't have a blockchain. And we made it such that you can do that, and then you can build any state machine you want on top of that, whether that's an EVM, whether that's something we've never thought of, whether or not that's SVMs, all the VMs in the world. But you can create something wholly new. You can use a Cosmos SDK app. You can do all of it, and you can drive it all with this execution. And this ties into kind of what I think of the life cycle of what it is to, this is just basically, I started with the life cycle of what it takes to build and deploy any sort of application. You have to build the thing, you have to deploy it, and then more specific to crypto and blockchains, you need bridging and integrations. Because if you don't have bridging, you don't have liquidity. And if you don't have integrations, then you don't have access to tools like MetaMask, Foundry, the things that really sticky that a lot of us are used to using. If you're, an LP, maybe you're using Fireblocks, these sorts of things are really difficult to get on board, and therefore to actually get people to use your awesome product that you're creating. And so this is kind of, when we think about it, it's like, the developers, how do we make it easier for developers to build, ship, and get all of those pieces out of the box? And that's kind of where we're headed towards. We have this CLI, which is really intended to bring a user experience, which I experienced a lot when I was building Web 2 apps, which is there's something I run on my machine. I can continuously update and test. I can test with production data on my local machine, and then I can run it in prod, and it's going to have the exact same results, making that as clean as possible. And from iteration of first time I'm building it to, wow, now I want to have my first launch deployment, to I want to do iterations and updates on it. Building things like this, it's simple and dumb, but it makes it a lot easier. And this is tools that are currently used by Forma. They've built and launched their chain. Since they launched, they have added some more precompiles and more steps to it. When they do that testing, they go and they take existing prod data and they run it through and they say, I'm making these changes. Let me make sure that this doesn't mess anything up for me. You can, as a sovereign chain, as a sovereign, someone building a crypto product, go iterate, test with production data, inject new data and test how that works, and then be able to ship it to people when you know that it's working. Also, we built this like modular chatbot. This was a hackathon project that we launched and tweeted about a couple times. I don't think it's actually currently up and running anymore. But this was built in a day. It doesn't use a VM at all. This uses just data sent in the format that it interprets. Custom data format, it gets sequenced in an order. And then you view the transactions in an order. And you can build normal applications in this way too. This is where I say back to, it's just a database technology. Like any other database provider, you pay the provider of the database some fee, much like I pay S3 for a Postgres database. And you can build a messaging app that posts all of its data on chain and is globally reproducible by anyone who wants to read the data. And so coming back to how do we actually cause and help people to innovate? Josh has talked about 6 boxes before. Here are our roughly 6 boxes. I think there's actually 5 on the screen. Oh, that's 6. I can't count. Engineers, we can't count, we just build things. But the idea here is that in different points here, we can do different sorts of integrations and different work. So the rollup, I talked about how we can work on our state transition function and improve that. In this box that we call the composer, this is a data submission loop. So this you can think of as your order flow. You can do things like build special sequencing rules. You want app-specific sequencing rules. You can build those and change the way that data gets submitted. You want to potentially aggregate information that came from other rollups as well into your application. You can innovate at that conductor level. That reads data in and drives it up to the chain. So there's different layers here for us to innovate, and we can change each one of them. And they don't necessarily need to be the same team, the same people, but we can change all of them. Making it a lot easier when it's componentized. It's in separate boxes for us to actually move, ship, and test. Idamar, who's here, one of our engineers and researchers, put this together on how you can integrate Suave with an Astria rollup. And the idea here is that, again, we want to make it as easy as possible. I think this took a month and a half to throw together and get a prototype working on. The idea is, how can we make it as easy as possible to test these things? Because we've been talking up until, I know there are other Suave applications that have been in the works, but up until I saw this, I hadn't seen someone actually play with Suave and test it and run it against data. And so the idea here is, how can we actually take these things and ship them? Because one of the things with crypto being a financial Rails product, a product which all of us use, is that if you don't test it in production, you don't actually know how people are going to use it. Because if you can't have people play online poker and then go play real poker, it's not the same when real money is involved. And so when you do things like this, you can do something like an A/B test. You can launch a thing and say, how is it going to work for a while? And if it doesn't work, you say, didn't work, we're going to shut it down. And you can do tests like this and say, okay, we can actually test. This is one of the scary things about crypto. And we want to make it as easy as possible for people to run, ship, test, and integrate. And so I'm going to say we want to innovate here by, and I said I'm a tech boomer. I think we can be a little bit more boomer. And that means that we can do boring things like Jira is good, actually. We can design our products, we can iterate on them. Because of the nature of shipping crypto and blockchain protocols especially, it's very similar to building on-prem software. When you're building on-prem software, you have to have deliver by dates, you have to have hard cuts, you do all of this. When you're building most Web 2 applications the way we're able to build them because the database can be upgraded at any point in time, you're able to do this something that looks a little bit more like this classic software development lifecycle. And we're able to build, test, deploy, and do all of that in cycles. And usually along the lines here, we're doing like A/B testing, and we're making sure that the thing works the way we hoped it would. If it doesn't, we roll it back. We can do all of that. And by moving some of these things into different states and separate boxes, making it such that you can innovate on just the state transition function. You don't have to be married to, oh, we have to use the EVM, oh, we have to use this. We can make it a lot easier for you to go through and do this normal cycle. And that's all I have in the slides here. I think we have a couple minutes here so we can take some questions if anyone has any.